Hi, today we're going to learn about Calculus 2 and we're going to do integration by parts, and this is example 1. So, before we start by integration by parts, here are some of the rules. So, for an indefinite integral, where there's no limits, you have the rule, it's the integral of, this is the formula, it's the integral of u dv equals uv minus integral of v du. So basically you got to find what's your u and your v, but there's a trick we can use to figure out which is our u and which is our dv. So we have what's called the Leite. So for Leite we have the logs, inverse trig, algebra, trig, and then exponential. And notice that I said trig and exponential can be interchangeable. Yes, they can be switched. So you can put the you can do the exponents first and then trig first. It doesn't really matter. So basically, so whichever comes first is your u, and then what comes last is your dv. For example, if you had the integral, you had a log, and then you had an algebra, your u would be the log, and then your a will be the algebra, right? So, okay, so like an example would be integral of x e to the negative 2x. This is our first example. So our u would be our x, and then our dv is the e to the negative 2x. Basically, you just have to remember that the u is the one that can be that won't be complicated, right? Because when you take the derivative of x, or du is just 1, right? Right, you wouldn't use cosine as your u because it could keep on going, right? So we'll do more. I'll show you when we do the examples. And then for the definite integrals, it's the same rule, but you just have to put the limit. So remember the fundamental theorem of calculus. So you have to put a to b, and then integral of, it's the same rule but with limits. So let's start with the first example. So we want to integrate by parts with this x times e to the negative 2x times dx. So what I will use is remember the Leite, L-I-A-T-E. Here, let me put it right. I'll write it down here. I-A-T-E. So what would be our u? We have an algebra, right? We have an algebra, and then we have an e to the negative 2 is the exponent. So our u is going to be, since we have an algebra first, so our u is the x, and then our dv is the exponent, which is e to the negative 2x, and then don't forget the dx, those the dx. So remember, I'm using this rule, u dv equals uv minus integral of v du. So that's why we got to find out our u and our v. So yeah, the dv always has a dx. Okay, so first, now we got to find the derivative of u, or we could call that du, which is just 1. And then remember, when you always take the derivative, you always have to put a dx. And then to find the dv, to find v, you basically take the integral of e to the negative 2x. And I will do it again. Do it because you probably need to use substitution. So we got to take the integral of e negative 2x dx. So remember, we're gonna have to take the we're gonna use u substitution. So u equals I'm gonna use u as negative 2x, and then du is -2 dx. Right? Okay, so let's look at we don't have a -2, so we have to get rid of this -2. So I'm going to multiply both sides by -1/2. -1/2 du equals, and now we have a dx. So now we can simplify. So we take the integral of that, and then remember this is a constant, so I'm going to put it in front of the integral. So that's -1/2, and then e to the u times du. So e to the u, the integral of e to the u is just e to the u, and then make sure you times it by -1/2 plus c. So, and then I'm going to put it in. So that's going to be -1/2 e to the u, which is -2x. So our v is this thing. This is our v. So our v is -1/2 times e to the -2x. And we don't have to put this plus c right now. Yeah, we don't have to put, for v, we don't have to put this c. So now we're going to use this formula, uv minus integral of v du. So what is our u, which is x. So it's going to be, and our v is -1/2 e to -x. So I'm going to, that will be, if we combine that, that'd be -1/2 x times e to the -2x. Minus the integral of v du. So v du is -1/2 e to the -2x, and then du is just dx. Okay, so I will make this, I'm going to take out this -1/2, so I'm going to have a negative and then -1/2, because that 1/2 is a constant. So e to the -2x dx. And remember, when we take the integral of e to the -2x, we get a -1/2 e to the -2x, right? So that's going to be the integral of e to the -2x is this, -1/2 e to the -2x. And then don't forget about this, two negatives. So that's +1/2, and then plus c, and then -1/2 x e to the -2x. Oops. So your final answer should be, I'll put it right here. Okay, so this should be -1/2 x times e to the -2x minus 1/4, because 1/2 times -1/2 is -1/4, e to the -2x plus c. Let's see, can we simplify this even more? I think we can. We can factor out a negative e to the -2x. So we'll factor that out. So here, that'd be negative e to the -2x, and then I'm going to put brackets. So that would be x over 2 plus 1/4 plus c. This should be your final answer. So yeah, it's basically you just got to find your u and your v, and then just use the formula. And then all my examples are, they're all indefinite integrals, because there's no limit for right now. But maybe in the other examples I'll do some where I have limit boundaries. So let's do another one. So let's do this one. We have the integral of x squared times e to the x dx. So what am I going to use for my u? Let me write it down. So we have L-I-A-T-E. I will use u as our x squared because x squared is algebraic, right? And then our dv is, we have an exponent, so this will be our dv, so it's e to the x. So let's take the derivative of u, so that du, oh, don't forget the dx for the dv. So our du is 2x dx, and then our v, if you take the integral of e to the x, it's still just e to the x. Yep, e to the x. And I am looking at this, and I think we're going to have to use integration by parts twice, because let's use the formula. So the formula is uv minus integral of v du. So our uv is x squared times e to the x minus the integral of v du. So the integral is e to the x because that's our v, and our du is 2x dx. Yes. So I'm looking at this part, and it says we got to integrate again by integration by parts. So this is a integration by parts twice. So let's look at this part. What was our u? Our u is going to be 2x because 2x is algebraic, right? Algebraic right here. And then if you take the derivative of that, that's just 2 dx. And let's see our dv. Our dv is exponential because it's the last one. So dv is e to the x, and then if you take the integrate of e to the x, it's still e to the x. So we're going to use this formula again. So uv is 2x, our u is 2x, right? And our v is e to the x, so times by e to the x, minus the integral of v du, which is e to the x, and our du is 2 dx. And then I will put, and then we know the integral of e to the x is e to the x, and then we could leave out this 2, we could put it in front, so you're just left with 2 ex, right? So it's the integral of this is negative 2 to the ex plus c, and then bring this down, so that's 2x e to the x. And then remember, I'm going to put brackets here because remember we have to there's a negative sign, so I'm going to just distribute this negative, bring down the x squared, x squared times e to the x, right? So let's distribute this negative. So you're left with negative 2x e to the x, and then over here we have two negatives, that becomes positive, plus 2ex plus c. And then bring down this x squared times e to the x, so we have x squared ex minus 2x times ex plus 2e to the x plus c. Can we factor out anything? We can. We could factor out an ex. So I'm going to factor that out. So I'm going to factor e to the x, and then I'm going to use brackets. That would be x squared minus 2x plus 2 brackets, and then don't forget the plus c. And this should be your final answer. Yeah, so for this one we had to integrate it by parts twice. So this one we have x sine of 3x dx. So let's do the Leite. Let's see, so what will be our u? Our u will be x because it's algebraic right here. That's algebraic. And then if you take the derivative of that, that would be just 1 dx. And then our dv is sine of 3x dx. And then our v will be negative 1/3 cosine of 3x. And if you don't know how I got that, I'll show you. It's basically integration. So sine of 3x dx. So this is where you have to use this u substitution. So if I let u equals 3x, du is 3 dx. We don't have 3 dx because we have a 3x inside the parentheses, so we have to get rid of this 3. So I'm going to multiply everything by 1/3. So that's 1/3 times dx. So it's the integral of sine of u, and then this 1/3 can go in front because it's a constant. So the integral of sine is negative sine. The integral of sine is negative cosine, so it would be negative 1/3 cosine of 3x, because u is 3x. So that's how I got negative 1/3 cosine of 3x. Now I'm going to do, remember it's uv minus integral of v du. So our u is x, and our v is this whole thing, so times negative 1/3 cosine of 3x. Okay, so minus the integral of v du's, so negative 1/3 cosine of 3x. So let's move this constant, because negative 1/3 is, we'll put it in the front, so it's negative 1/3 cosine of 3x. So for this integral of cosine 3x, you could we'll have to do is use substitution again. So we can use u equals 3x, and then our du is 3 dx. But we don't have a 3, right? We have a 3x. Oops, don't forget this dx. So yeah, so that's why we want to get rid of this 3, because we have just a regular dx. We want dx by itself, so we're going to multiply everything by 1/3. So now we have 3 dx. Good, that's what we want. So this 1/3 goes in front, because it's a constant. So the integral of cosine of u, which is just positive sine of u, and then don't forget this 1/3. So then you just plug in what is sine, plug in what is u, so it's 1/3 sine of u, which is 3x. Okay, so it's two negatives. Okay, so that becomes 1/3. And then don't forget this 1/3, this other 1/3, times by sine of 3x. So this becomes 1/9, so our final answer should be negative 1/3 x, which I got from here. I'm just putting the 1/3 in front. Negative 1/3 x cosine of 3x plus, remember, plus two negatives and plus 1/9 sine of 3x plus c. Yep, here's your final answer. Let's do this one. So we have the integration of x squared cosine x dx. So what is our u? Our u is going to be x squared. So take the derivative of that. That would be 2 du would be 2x dx. And then what would be our dv? It's trig, right? So that's why algebra is first. So our algebra is x squared, which is our u, and then our dv is our last because it's a trig. Trig is after algebra, so our dv is cosine x dx. And then v is basically integration of cosine x, which is positive sine x. So we're going to remember the formula uv minus integral of v du. So what is our u is x squared times sine x minus the integral of v du, which is sine x, and our du is just 2x dx. Yes, we're going to have to do integration by parts. So let's look at this part. So what is our u? Is 2x, because 2x is our algebra, and then take the derivative of that is 2 dx. Our dv is trig, which is right here, so it's going to be sine x dx. And then take the integral of sine x, which is our v, which is negative cosine x. Okay, so remember this negative, so it's going to be negative. I'm going to put parentheses. So uv, which is 2x, times negative cosine x minus the integral of negative cosine x, because that's our negative cosine x is our v. Remember v, and then du cosine x, and our du is 2 dx. So if you take the integral, this 2 is a constant, so you could put it in front, so it's a negative cosine. I'm also putting this negative in front, cosine x dx. So the integration of cosine x is just positive sine x, and then remember the 2 should be in front of here, so That's going to be positive 2 sine x. And then bring this down. So we get 2x times negative cosine x plus 2 sine x plus c, and then don't forget you have to distribute this negative, and then so if you were to bring don't forget this part, this x squared, so bring that down, so you're going to get x squared times it by sine x plus 2 negatives, right? 2 negatives become positive, so it's 2x cosine x. Distribute this negative, so it's negative times positive, so it's going to be negative 2 sine x plus c. This is your final answer. Okay, let's do another one. Let's do x times ln x dx. So I gotta figure out what's our u and our v, so liate. So we have an algebra and a natural log, so this is a log, and then this is our algebra. So which comes first? The log, so our u is going to be ln of x, and if you take the derivative of that, that would be 1 over x dx. Right, and then our dv is the last one, which is algebraic. So dv equals x, and then don't forget the dx, x dx. And then if you take the integral of that, you should get 1/2 x squared. So it's, remember the uv minus integral of v du. So our u is ln of x times 1/2 x squared minus integral of v du, which is 1/2 x squared times du, which is 1x dx. Let me clean this up. So this should be, we have a 1/2, so it's a constant, so I'll put it in front. And then x squared over x is just x dx. And we know that the integral of x is 1/2 x squared, so it's 1/2 x squared. Then also don't forget this negative 1/2, right? Negative 1/2 plus c. And then don't forget to bring this down. So your final answer should be, I'll put it right here, x squared over 2 of ln x minus x squared over 4 plus c. Let's do this one. Ln of x squared times dx. So liate, we have a natural log squared, and then times it by 1 dx, right? There's an invisible 1 right here. So our u is going to be this whole thing, ln x square and then our dv is just the regular 1 dx, or you could just call it dx, or 1 dx, it's the same thing. Take the integral dx, which is just regular x. Okay, this one, we gotta take the derivative of this one. This is kind of tricky. It's the power rule, right? So it's 2 times ln x. We're gonna use the power rule and the chain rule, right? 2 times ln x, and then times by the derivative of ln x. So it's 2 ln of x, and then 2 minus 1 is 1, so there's a 1 degree, but I don't want to put it, it's just 1. And then times it by the derivative of ln x, which is 1 over x dx. And if you were to clean that up, it would be 2 ln of x over x dx, right? So I'll put it, so it's, remember, it's uv minus dv, uv minus integration of v du. You should memorize this right now. It should be, you should memorize, it should be memorized. So our uv is ln x square times by x minus the integral of v du. Here's our v and here's our du, so it's x times 2 ln of x over x dx. If you were to clean this up, it will look something like this. 2 ln of x times dx. Don't forget this part, right? So over here we're going to have to do integration by parts twice. So what is our u? We have a 2 ln x times dx. So we have a natural log. So our natural log's first, so that means our, according to Leite, our u is going to be natural log of x, and then if you take the derivative of that, it's just 1 over x times dx, and our dv is, remember, it's whatever left, it's our algebra, or 2 in our dx, so it's going to be 2 dx. If you take the integral of that, that is just 2x. So this will be going to be ln of x times 2x minus the integral of v du, which is our v is 2x, and then our du is 1 over x dx. That simplifies as just regular 2x because the x cancels. 2 dx. And that just becomes, the integration of 2 dx is just 2x. And then don't forget the negative. So that's negative 2x. And then bring this down. I'm going to put the 2x front. 2x of ln of x plus c. And then don't forget you have to distribute this negative. So I'm going to put brackets right here. So, and then don't forget this part, the ln x squared. So your final answer should be L times ln of x square minus this, there's a negative, so it's going to be minus 2x ln of x plus 2 negatives. Remember, 2 negatives equals positive, so it's plus 2x plus c. So yeah, so when you have a log or a natural log, it always comes first because logs and natural logs are the same thing. Okay, what about this one? Let's say you have the integral of ln of 3x minus 2 dx. So this one's a little tricky, I'm not gonna lie, but I'll show you step by step. Okay, so what is our u? Our u is going to be this whole thing, ln of 3x, because and then because our L is natural log, so it's natural log of this whole thing. And then if you were to take the derivative of that, you're going to have to use the chain rule. So it's 1 over 3x minus 2 times it by the derivative of 3x minus 2, which is 3, and then the dx. Clean it up, it will look something like this. 3 over 3x minus 2 dx. And then what is our dv? Our dv is just 1 dx, or just dx. And if you take the derivative of that, or 1 dx, it should just be just x. So we got our u times v is x times ln of 3x minus 2, right? Because our u is this and our v is this, minus the integral of v du, which is our v is x, and our du is this whole thing, 3 over 3x minus 2 dx. And if you were to clean this up, it's going to look something like this. 3x over 3x minus 2 dx. So, okay, this is the part where I got confused. Okay, so what you do is, like, you could do long divisions where you put the, this 3x minus 2 is our divisor, and then this 3x is just our dividend. It's like, remember the box? So it's going to be, I'll put it right here. Our 3x is our dividend, so it's inside the box. And then our 3x minus 2 is our divisor, so it's outside. So I'm going to use 1 times 3x minus 2, so it's 3x minus 2, right? And then put it negative, distribute that negative, so this 3x comes out, cancels, and then 2 negatives becomes positive, so it's going to be plus 2 plus the remainder, which is 3x minus 2. So this thing, it will be simplified as 1 plus 2 over 3x minus 2. Notice I put parentheses, so that means we're going to do it individually. So what is the integral of 1 dx plus the integral of 2 over 3x minus 2 dx? So for this one, this is really easy, right? It's just x. The integral of 1 is just x. And for this one, you will have to use substitution. Here, let me write it right here. 2 over 3x minus 2 dx. So use substitution. So u equals 3x minus 2. Take the derivative of that, it's just 3 dx. Oh, hold on. See this 2? It's a constant, so I could put it in front. So it should have been 2 over 3x minus 2. But that's okay, we still use the u substitution. But the thing is, we don't have a, whoops, don't forget the dx. The thing is, we don't have a 3 anywhere. We only have a regular dx, so let's get rid of this 3, so I'm going to multiply everything by 1/3. Good, now we have a dx by itself. So, see, this 1/3 is a constant, so I'm going to bring that down, so it's going to be 2 times 1/3, which is 2/3, right? 2 times 1/3 is 2/3. The integral of 1 over u du. So the integral of 1 over u is just ln, which is ln of u, which is 3x minus 2. And then don't forget the 2/3, because it's a constant. So it's going to be x plus 2/3 of ln 3x minus 2 plus c, and then remember we have to distribute this negative, and then don't forget to bring this down. So our final answer should be x times ln of 3x minus 2, and then distribute this negative, so it's going to be negative x minus 2/3 ln of 3x minus 2 plus c. This should be your final answer. So yeah, this part where I just did long division, and then that's how I got, it breaks it up into 2 more integrals, right? 2 plus 2 over 3x minus 2. And then I just did u substitution, so that's how I got this part. So yeah, let's do another one. Let's do a sine inverse. So let's do the sine inverse of x times dx. So let's do our Liot. We have inverse, right? This is the inverse trig. So that will be our u, trig. That will be our u, so our u is going to be sine inverse of x. And then our dv is 1 dx. Take the integral of that, that's just x. And then take the derivative of u, or du. That would be, remember the derivative of sine inverse is formula, so it's 1 over square root of 1 minus x squared dx. Good. Okay, so what is our u and our v? So our uv is x times sine inverse of x minus the integral of v du, which is x times 1 over square root of 1 minus x squared dx. If you were to clean that up, that would be x over 1 minus x squared dx. So let's look at that. This one we will have to use u substitution. You can use u or w if it confuses you, but for me I'm just going to use u. But it's not wrong if you used w, because sometimes people could get confused, but I won't. So u equals 1 minus x squared, and then derivative of that is negative 2x dx. We don't have, let's look at this, we have an x dx, but we don't have a negative 2, so let's get rid of that negative 2. So I'm going to multiply everything by negative 1/2. So that's just x dx, right? So it's going to be the integral of this constant, so I'll put it in front, 1 over square root of u times by du. So that's like saying u to the negative 1/2, right? Du. And you know how to take the integral of this, so it's negative 1/2 plus 1, so 2 over 2, so it's 1/2. So that would be u to the 1/2 over 1/2, and then you could do brackets and multiply everything by 2, so that should be 2 to the u 1/2. So, and then plug in the u, so it's 2, what is 1/2 is the same thing as square root, and our u is 1 minus x squared. So it's yes, so there's going to be two negatives, so negative, remember this negative and then this negative, so negative 1/2 bracket of 2 times square root of 1 minus x squared plus c, and then don't forget this part, x sine inverse of x. So let's look, 2 negatives becomes positive, and then let's get rid of this 2 because the 2 cancels. So our final answer should be x times sine inverse of x plus square root of 1 minus x squared plus c. So yeah, this one we had to do use substitution twice. Okay, next one. This will be our final one. Yeah. So we have the integration of x times secant square x dx. So let's do our Leite. We have a algebra and a trig. So here's our algebra and then here's our trig. So which one comes first? The algebra. So our u is going to be x, or the algebra. Take the derivative of that, it's just dx, or 1 dx, it's the same thing. And then our dv is secant square x dx. This one comes out really nice because if you take the integral of secant square x dx, it's just tangent x So now you just got to do the u times v, which is x tangent of x minus the integral of v du, which is tangent x. Du is just dx. Okay, so we don't know the integral of tangent x, so let's simplify it even. What is tangent? Tangent is the same thing as sine x over cosine x, right? And then times it by dx. So for this one, we could use u substitution. So we'll use u as our cosine x. And then our derivative of that is just negative sine x dx. Let's see, we have a sine x dx, but we don't have a negative, so let's get rid of this negative. So I'm going to multiply everything both sides by negative. So now that we have a sine x dx, good. So let's put that negative in front. So negative, and then don't forget this negative. So it's 1 over u times by du. So that's going to be a natural log of u, which is cosine x, plus c, and then don't forget this negative, so 2 negatives is a positive, and then bring this down, which is x times tangent x. Yep, that is your final answer. So it's x times tangent x plus ln of cosine x plus c, and then I will use absolute value for this part. Yep, and that's it for this section.